So evaluating f of x plus h, I'm plugging in x plus h for all of my x's. And again, critical that you keep, especially when you're plugging in a binomial, that you keep it in parentheses. And then we're just going to simplify out. So using your shortcut for how to square a binomial, just to make things easier, x squared plus 2xh plus h squared. We have to distribute our minus sign on the next binomial plus the 3 at the end. Then we have to distribute our 2. So we get 2x squared plus 4xh plus 2h squared minus x minus h plus 3. And there's no like terms, yes? Is that good? Okay. So we know how to do f of x plus h. B is going to add a layer onto that. And this is something we're going to be dealing with a lot in calculus. The f of x plus h, which we've already done, so let's not redo it. We'll steal that whole thing for the f of x plus h. So 2x squared plus 4xh plus 2h squared minus x minus h plus 3. There's my f of x plus h. Put a giant set of parentheses around that. Minus, and the next thing is f of x. Now that's just the original function, right? So we're just going to take out f of x and replace it with the original function. So minus, big set of parentheses because f of x is a trinomial, 2x squared minus x plus 3. All divided by h. And then we're going to simplify this, which is just going to be distributing your negative and combining like terms. So we have a 2x squared minus a 2x squared. Safe to cancel those? Okay. We have a 4xh. Do you have any other xh terms? No. We have a plus 2h squared. Any other h terms? No, so that's just being brought down. We have a minus x, and then we do have another x term, minus a negative x. So that's going to be a minus x plus an x, which is going to be a wash. You have a minus h, which has no other like terms to be combined with. And then you have a plus 3 minus a 3, which is another wash. And when you're done with that step, the 3 terms in the numerator all do have an h. So I can kind of divide each term by h. So 4xh divided by h just becomes 4x. 2h squared divided by h becomes 2h. And negative h divided by h becomes minus 1. And that would be your answer. This is called the difference quotient. This right here is the formula for the difference quotient. And so if you're ever told to find the difference quotient for a function, you need to know that formula. And obviously you need to know how to algebraically do it. Does that make sense? Okay. So memorize that. F of x plus h minus f of x all over h. That's your difference quotient if you ever see it. Now, what is this? Okay, so calculus in general kind of starts off with this big idea of what is the slope of a curve? Okay, now lines have the same slope the entire time, but anything with a curve, which is most functions, anything with a curve has a slope that's constantly changing, right? We have a negative slope, still negative slope, but not as steep, a zero slope right at the vertex, a positive slope, but not so steep, and then that positive slope gets steeper and steeper, okay? So we have this slope that's constantly changing, and what we initially do in calculus is we figure out how to find the slope of any function at any given point in time. So what if we want the slope right here? Okay, and this is where the difference quotient will help us. If we wanted the slope right instantaneously at that point, okay, we're going to look at the slopes of different lines as we get closer and closer to that point. All right? So one of the first things we'll talk about are secant lines and tangent lines. Does anybody know what a secant line is? That word? Secant of a circle. You gonna do that in geometry? What do you think, Stephen? Say it again. Correct. Like a secant of a circle is a line that goes through it at 2 points. Same is true for the secant of a curve. So we would start with, let's say, and I'm going to really blow this up to magnify what's going on. I kind of wish I didn't do my parabola so steep. But here's a secant line. Okay, that's a secant. Now, I have 2 points here. Let me explain kind of why they're labeled the way they're labeled. The first point is the point that we're interested in. We're interested in the slope at that point. It's just x comma y, essentially, x comma f of x. The next point is h units to the right. So if this is x, then we're going h units over to get to the next point, which has got an x coordinate of x plus h. Okay, this is h units over. Okay, so the new coordinates, the new x coordinate is x plus h, the new y coordinate is f of x plus h. So if you're going to find the slope of this secant line, slope formula, y2 minus y1, over x2 minus x1, and then when that simplifies, you see the difference quotient, yes? So it's f of x plus h minus f of x, and then on your denominator, x minus x cancel, and it's just all over h. That's where your difference quotient comes from. It's the slope formula for a secant line, okay? All right, so is the slope of this secant line the same as the slope right at that point? No, okay? The slope of the curve right at that point would be the same of the slope of the tangent line at that point. What's a tangent line? Jalen? Only 1 point. One and only 1 point. So the tangent line is going to look like this. So is the slope of our secant line and the slope of our tangent line the same? No. Now I wish I had kind of an animation here, because what I would do is I would start sliding this point down the curve. And as I do that, if I kept the secant line kind of attached to it, what would happen to the slope of the secant line? It would match the tangent line. It would get closer and closer, right? If I were to drag this down and the secant line just kind of kept connecting the 2 points, the slope of the secant line is going to approach and get closer and closer to the slope of the tangent line. Yes? So by sliding this point closer, I'm actually shrinking h, right? I'm really just kind of pinching these 2 points closer so that H is getting smaller and smaller. So your one point is X, has an X coordinate of X, and the other one is like X plus 0.00000001. So I'm pretty much pinching these points closer and closer until they're essentially going to be on top of each other. It's going to look like they're on top of each other, even though they can't technically be on top of each other. Yes? And once you get that closer and closer, once that distance H approaches 0, gets as close to 0 as possible without actually being 0, now the slope of your secant line is going to be one and the same with the slope of the tangent line, and you're going to have the slope of the curve at that point. Does that sort of kind of make sense? We're not going to do so much with the meaning behind that right now. We're really going to practice just calculating the difference quotient. But that conceptual background, and I'll represent that all in February or March when we get to it, but that's kind of the basis behind finding the derivative, which is finding the slope of a curve at any given point. And I'll leave it at that. Okay, but that's just an intro for those of you who were able to follow that. If not, like I said, no big deal. We're just really working on the calculation. Okay? Any questions? Okay. Totally switching gears to piecewise functions, which you should have done last year. Okay, here's a piecewise function that's giving the cost of a cell phone bill as a function of t, which is the number of minutes you've been on the phone. So if t, the number of minutes used, is anywhere between 0 minutes and 60 minutes, your cell phone bill is $20. Once your time gets over 60 minutes, your cell phone bill is calculated by 20 plus 0.40 times t minus 60. Can anyone kind of interpret and explain in words to the average person what this formula means about how you're being billed? Go ahead, Jack.
For every minute over 20 minutes, or 60 minutes.
Right. Very good. For every minute over 60, you're being charged an additional 40 cents per minute. So it's like the $20 is buying you 60 minutes. Once you go over 60, every additional minute is 40 cents. Perfect. So for example, 61 minutes, you're paying your original 20, and then 61 minus 60 is going to give you the fact that you're 1 minute over, and 40 cents times that 1 minute. So you'd pay $20.40. Does that make sense? Good job, Jack. So just evaluating C of 30. Who can tell me what I do here? Lily W. What's C of 30? 20. Okay, your input is 30. That falls into the first piece here. And so you input 30 and you're going to get 20. C of 100. We're going to plug 100 because it's greater than 60. We're plugging it into this, so 20 plus 40 cents times 100 minus 60, which means we were 40 minutes over. So we have 40 minutes being charged at 40 cents. Let's break out our non-calculator skills. What's 40 times 0.40? Good. You could do 40 times 40 and get 1,600 and then just move your decimal place over twice. There's one way of thinking of it. You could also think of it as 40% of 40, right? 16. So there's different ways to think about this, and then your bill is $36. And interpret the pricing plan. Jack already did that for us. Okay? Any questions? All right. Interval notation, which you've done last year. Stating intervals on which each function is increasing, decreasing, and constant. So in this first one, we'll do part 1. Over what intervals is this increasing? Raise your hand if you think you can tell me. Are you all done, Lucy? Do you want to hang out? Okay. Did you bring your pass or no? All right, so just go back with that. Thank you. Only 2 people can tell me interval notation. Stop it.
I think I know.
Nathan McMillan, I know you're lying. What's the interval along which this is increasing?
0 to 2. Or -4 to 2.
-4 to 2. Very good. So, what made you say 0 to 2?
I saw
Right, okay. So, the first main thing to reestablish what I'm sure Mrs. Ziggy stressed with you last year is anytime you're dealing with interval notation, other than when it's the range, because in the range you're definitely looking at the y-coordinates, you're only looking at your x-axis numbers. So don't let the fact that it's increasing from 0 to 8 on the y-axis cloud your perception here. All interval notation looks at the x-axis numbers. So left to right, when does it start increasing? At -4. When does it stop increasing? At 2. And Nathan, are we using brackets, parentheses, a combo? What are we using here? No. We actually are always going to use parentheses for things like increasing, decreasing, and constant. All things that have to do with the slope, we're using parentheses. And here's why. Because at -4, at that exact moment, the graph is not actually increasing. It's actually, there's a slope of 0 right at that turning point. So it's not actually a positive increasing slope. Okay, does that make sense? Stephen? For the 2? Okay, so when we get to the second part, first of all, tell me what the decreasing numbers are. Yep. Bold parentheses, okay. Right, there, that's a good fix, right? See, it's only natural to almost look at the y-coordinate, but you have to tell yourself, no, no, no. So from 2 to 7, okay, and I'll talk about that. When you actually hit like a hard point, and that's an end point, and it doesn't go any further, there's actually no such thing as a slope at that point. There's a negative slope coming into it, but at that exact point, we'll find out more in calculus, but there is no slope there when it reaches a hard end point. Does that make sense? The slope is not negative at that point. There is no slope at a point.
Yeah, I was asking about like constant values. Why would you use brackets?
Like here?
Yeah.
Because still, there is no slope at that end point, and there's also no slope at corner points. There's no such thing as a slope at a corner point. There is no slope there. Does not exist. Okay? And we'll see a lot more of that in calculus and why that is and so forth. But for now, just take me for my word. End points, sharp corner points have no slope. So there were 2 intervals that this was decreasing. So as Stephen told us, from negative infinity up until -4, it's just been decreasing the whole time. Then we obviously have it increasing for a small stretch there, and then it starts to decrease again starting at 2 up until 7, okay? Increasing, decreasing, and constant intervals will always be parentheses. And the third one for part A has no constant. There's never a constant interval, so I'll just put does not exist. backing up to the second one again, I didn't mention it, I just kind of wrote it and took it for granted. If there's two intervals along which something is decreasing, we're going to kind of join them with the union symbol. Okay? So, keep that in mind. I'm actually going to add 4 and 5 here. For 4, I want to know where this is. I'm using Roman numerals, who knows why. I want to know where this is positive and negative. Not the slope is positive and negative. I want to know where the overall function is positive and negative. And again, you should have done this last year. So positive means what? If the function is positive, not the slope is positive, the function is positive. Who can tell me what that means? If class participation was a grade, you two would get a 100. Taylor? Above the x-axis, correct, with positive y coordinates, so above the x-axis. Adam, can you tell me what the positive intervals are? Yeah, we unfortunately, even though we're above the x-axis, this whole thing, we kind of have to break it up because we're not actually positive at -4. So negative infinity to -4, and that -4 is going to get a parenthesis because it's not actually positive there, it's 0. But then we're going to pick right back up at -4 to, what did you say, Adam?
0.
Is it positive still here? It's still above the x-axis, so we don't need to cut anything off here. So from -4 until 5. And 5 has a parenthesis again because it's not actually positive at 5. And then when is this graph negative? Liam?
From 5 to 7.
5 to 7, and what kind of symbols? Not on the 7. Do you see why?
Yeah, it includes that point.
Right, 7, that point included does fall below the x-axis, so it does have a negative y coordinate. So we're going to include the 7. Take your time with these. We all get them, you know, when it's explained and so forth. But if you rush through them, it's easy to, whoops, I looked at the y coordinate, or whoops, I didn't think about the nitty-gritty detail of is it included or not, okay? But for the sake of making your life easier, anything increasing, decreasing, or constant, anything referring to the slope, always parentheses. Okay, it's the positive and negative that we have to worry about, brackets or parentheses. Okay, and what is the relative max and min? The relative max, okay, is any turnaround point, for lack of a better word, okay? So this is a relative max. Now it depends, you have to pay attention. Are they asking for the relative max value or the relative max point? And here I kind of left it open. The relative max point is 2.8. The relative max value, you would just say, is 8. Now, versus the word absolute, okay? The absolute maximum here does not exist. Who can explain why it doesn't exist? Michelle, what do you think? I can't hear you. Right, it's when you go towards negative infinity, the y coordinate's always increasing. So it's headed off towards positive infinity as far as a range is concerned. There is no highest value in the range because it's going to infinity. So the absolute max does not exist. So there is no absolute maximum point. There is no absolute maximum value. Does not exist. talking minimums. Relative minimum. We do have a relative minimum point. It's negative 4, 0. And we do have a relative minimum value. That would just be the y-coordinate of 0. This is not a relative minimum. Look up at the graph. This one's not relative because it's not a turnaround point, okay? Because it has to be relative to the points on both sides of it. So relative to the points on the left of it, it is minimum, but there is no relative points on the right of it, so therefore we can't call it a relative minimum. It is, however, the absolute minimum point. And that would be 7, negative 12 if you're asked for the point. And the absolute minimum value would be negative 12. Does that make sense? Okay? I'm going to go through B, just talk through it. I'm not going to write it down. This is increasing from negative infinity up until negative 2. It is decreasing from 5 to infinity, and it is constant from negative 2 to 5. All of those are with parentheses because those are slope, okay? Now, when is it positive? It is positive from negative 6. Do we include that or no? No, so negative 6 with parentheses. At negative 2, is it still positive? Yes, so I don't need a little, even though the graph breaks, I don't need to break this up. It is positive from negative 6 with a parenthesis up until, I'd have to give you this 0.60, let's say. Up until 6 with a parenthesis. Yes? It is negative from negative infinity up until negative 6. Again, infinities always have parentheses, and the negative 6 here would have a parenthesis because it's not actually negative there. And then from 6 to infinity, also with parentheses. Keep looking. There is no absolute maximum here. This is a concept. There is no absolute maximum. It's not 4 because it doesn't really reach 4. It's kind of like 3.99999, but then the next person could say 3.9999999. And we could go beyond that. So there is no maximum value. Does that make sense? Alrighty, your homework's there at the bottom.